talk about four important subjects, four important definitions in statistics, which is sensitivity, specificity, positive predictive value, and negative predictive value. Many statistical clinical trials and studies use these definitions, and let's go throughout the four of them and try to understand what does each one, what does it mean negative predictive value, what does it mean positive predictive value, and etc, and how they are calculated as you can see here. So let's start with sensitivity, which tells us by definition high sensitivity means that the test is good at detecting the condition when it is present. Namely, if I have a sensitive test, so I know that if the patient is negative in that test, because it's so good at detecting the condition when it's present, so if the patient is negative in that test, so I know it quite confidently that the patient is negative. Note how I said this. I didn't say that if because it is good in detecting condition when it is present, I didn't say that since that if the patient is positive in the test, so it's probably that the patient is positive. No, I didn't say this because even though high sensitivity means that the test is good at detecting the condition when it is present, it can also detect it when it is not present. So so you can use sensitivity to say it's very good for detecting if it's present, for detecting that the patient is, let's say, diseased. So if it's so good in detecting, everyone, even false ones, will be considered positive. Therefore, it's very sensitive. Even little hesitation will make it say that yes, it's positive. So if we're talking about diseases, so the test will very quickly say that the patient is positive, let's say like this, even if there is a doubt. Therefore, if the patient is negative in that test, so it's quite confidently that if the test is as high sensitivity, so if the patient is negative in that test, probably it's negative. And the calculation we will talk about. Okay, now, what does the calculation for sensitivity says? It says true positive. Take all the true positive, namely if we are looking at the table of the data, let's say for example this one, and I have here the results of the test and here what happens in real world. So if I have the disease present, disease absent, and test positive for the disease and test negative for the disease, so what I take for sensitivity is this column. What I say is, look at the test, look at the disease present, look at true positive. How many of all the disease patients the test caught? If the test has high sensitivity, it will caught most of the patient with the disease. So take the true positive and divide it by the true positive plus the false negative. These are all the disease patients. So this tells me, this calculation, how sensitive is the test. Therefore, to calculate sensitivity, I take the true positive and divide it by the true positive plus false negative. True positive divided by the true positive plus false negative. Namely, I take all the true disease patients, and in the nominator, what the test caught. This is the sensitivity. So sensitivity again helps us rule out if the test is negative. Namely, if the test is negative and the test is very sensitive, most probably the patient doesn't have the disease. Now, specificity. Specificity is high specificity mean the test is good at identifying when the condition is absent. Therefore, if a specificity a high specificity test is positive, I say that because if the patient was negative, the specific test would have caught that. So if a specific test said that the patient is positive, it is probably that the patient is positive. And you can see how I articulate the definition for sensitivity and specificity. In sensitivity, I'd used it to rule out, to say if the test is negative, so probably the patient is negative. In specificity, I said if the test is positive, probably the patient is positive. And look what specificity evaluate. High specificity means the test is good at defining when the condition is absent. Therefore, if I found anyone that has a true uh, has positive result in the true specific test, very specific test, so I say, okay, probably if the test is so specific, if the patient was negative, the test should have told me that the patient is negative, but the test told me that the patient is positive. Therefore, I say, because it's so good at saying that the patient is absent, even maybe true diseased patient is say it's absent. So if this one told me that the patient has the disease, the patient probably has the disease if the test has high specificity. So how do I calculate the specificity? I look at the disease here, this column now. I say, how good was the test? How good was the test with true negative? Namely, I look again at true negative and divide it by all of this column, all of the real disease patient, disease, all of the real absence disease. Namely, all of these patients are healthy. They don't have the disease. I look at what the test really said that they don't have the disease, divided by all the patients that don't have the disease. How good was the test in telling me that the patients of absent disease are really without a disease? As you can see, true negative divided by true negative plus false positives. Here are the false positive here. So specificity, true negative divided by all these columns from the reality column. Sometimes the test is here and the reality is here. Here in this table, the test is here and the reality is here. Okay, so sensitivity looks at this column, specificity looks at this column, and now we're going to the positive predictive value, which says to me, positive predictive value indicates how likely it is that a positive test result is actually true positive. Namely, if I have a result of the test, let's say positive, what is the likelihood? What is the probability that this true that I see right now is actually a true positive, a real true? So this here comes for this the positive predictive value, which takes the true positive from all what the test said that is positive. Namely, if I look at this table, where is the table? Where? Oh, here. I look at what the test said that it's positive and it really was positive, divided by what all the test said that is positive. As more as the test said correctly that the patients that test positive are really diseased compared to all the positive results of the test, I would say that if the test said it's positive, it's probably positive. So positive predictive value is calculated by taking the true positive results divided by true positive plus false positive. And you will tell me how true, how positive result is really a true positive result. This is the probability for true positive result. Negative predictive value is in the same idea, just with the negatives. Negative predictive value indicates how likely it is that a negative test result is actually a true negative. Namely, if I get negative from the test, how likely is that it's a really true negative patient? So the same idea, true negative now, how much the test was good at identifying the negatives. I take this true negative and divide it by true negative plus false negative, where the test was wrong in telling me that the patient is not diseased. So true negative, take true negative divided by true negative plus false negative. And tell me how much if I get a result that tell me that the patient is negative, it's really a negative patient. And here you can see how we calculate sensitivity Specificity, again, sensitivity, take true positive, divide by true positive false, oops, here, sensitivity, take the true positive, divide by this column, true positive plus false negative. Since specificity, this column, take false positive divided by false positive plus true negative. Positive predictive value, here, we are taking this row now, true positive divided by true positive plus false positive. Test negative, negative predictive value, which this column is correlated with. So I take true negative divided by true negative plus false negative. Here in the specificity, maybe I didn't say it right. You're taking the true negative divided by true negative plus false positive, yeah? Because here in the denominator, there should be the true result, the what the test identified correctly. Here's sensitivity for positive, here's specificity for negative. So I should have said true negative divided by true negative plus false positive. If I didn't say like this, I'm sorry. Okay, so those are the formula. These are the calculation. This is for example, and this was about sensitivity. Good at ruling out. Good at telling if it's negative. If it's negative, it's probably negative. It's probably the patient is negative. Specificity, if the test is positive, probably the patient is positive. Positive predictive value, what is the probability that if the test is positive, the patient is really positive, and negative predictive value, what is the probability that if the test is negative, really the patient is negative. Sensitivity, good at identifying condition is absent. Specificity, oops, sensitivity, good at detecting the condition is present. Specificity, good at detection the condition is absent. I think it's much better to think about it how I told it. Sensitivity, if the sensitivity is high, if the test is negative, so the patient is negative. Specificity, if the specificity is high, if the test is positive, probably that patient is positive. I think it's much better than high sensitivity means the test goes in detect the condition when it's present. High specificity means the test goes in identifying when the condition is absent. Because there can be many, for example, for specificity, there can be many examples that are negative, that are positive. The test concluded that they are negative, and you won't see it. I mean, false negative are not here. Okay, so I wish it was a little bit understandable, not very easy. Thank you very much. Thank for JGPT that construct this organized way, and that's it.